Well, hi, welcome to Chapter 10. Chapter 10, we get into inheritance, and inheritance is kind of it's a factor of object-oriented that really makes it very strong, and the fact that it saves us on code writing, because I can have one class and I can then kind of copy, or what we call inherit, all of those properties and methods into another object. Here's a book that I think is really good. It is uh, well, I can't remember quite what the cover is. I'd have to go back. But anyways, it's one of the I think it's Norton. But anyways, I try to put that in the notes. But here we have basically a square, a circle, a triangle, and an amoeba. Okay, and we see that a square has rotate and then play sound, rotate, play sound, rotate, play sound, rotate, play sound. So you notice they all have common methods. So those common methods, whenever we see anything like that, what we want to do is create what we call a superclass. And a superclass is a class that's way up here, and then the other shape classes then basically inherit from that. And then we will make these classes what are known as subclasses. So now we have shape has rotate sound, play sound, and now we have an arrow. Now whenever we see an arrow pointing to, and then the arrow is pointing up to that shape, we call that an is-a, is-a, is-a inheritance. What that means is um, a square is a shape. A circle is a shape. And a triangle is a shape. An amoeba is a shape. So what it means is it has all of the things that this shape has inside of it as well, and then anything else that it needs. So continue on. So um, now here's what's so now with inheritance, each one of those methods and or shapes will be different. So we know about overloading, so we have a constructor that's overloaded. That means it has different signatures within each of the parentheses so that it's expecting different things. So when it receives these fields, like a string int, for example, it's going to do something different. If that constructor, that method receives just a string, it's going to do something even different, because depending on the type of signature that we have. Well, with these types of classes, subclasses, and superclasses, we are going to do what's called overriding. That means we have the same exact parameters coming in. The program itself, or the method itself, is going to do something completely different. Okay, and so that's kind of what we're saying here is this particular class, the amoeba class, is going to do something completely different than the shape class or the other classes. So let's understand inheritance. So here we have a superhero class, and we have Fried Eggman and Panther Man, and they both inherit from the super. So Fried Eggman is a superhero, and Panther Man is a superhero. So they inherit all of the things and all of the instance variables and methods from the superhero class. So then after we inherit all those, then we can go ahead and override those methods by doing something completely different than what the original method did. So we have overloading, which has different signatures, overriding, which has the same signature but does something completely different. So here's an inheritance example. So here's some actual code. So let's do this. Let's actually go to some code, and I'm going to be on page 621. We're going to be looking at the grade activity. So looking at the grade activity, so here we have just a simple class. Looks like one instance variable. We have a setter, we have a getter, and then we have a method called getGrade, and there it basically returns a specific grade letter. So it's returning a char, which is just a letter depending on where you are in your point scheme. So not too bad. So that is just a simple grade activity. If we look on page 621, there we can see the UML document. And as you can see, here we have grade activity, and we have a private score, and it's a double data type. we've got get score, score, and then we have the get grade. Okay, so just a simple class, no big deal right there. So if we go to the grade demo program and we look at grade demo, there we see that we have a void static main, and we have a string input, a double test score. We say grade activity grade. So here we are creating an object from the grade activity class, new grade activity. Notice we have no, in fact there was no constructor. And we say input, so we get this from the J option pane, and we're looking for a test score. And we say double dot parse double input, so we basically convert it to a double and put it into the test score variable. And then I say J option pane, the grade for that test is, boom, not a big deal. So just a simple program. Okay, so nothing too exciting there. Okay, let's take a look at final exam. Now, final exam is where we start seeing this new inheritance feature. So let's say grade activity gives us everything that we need for just a generic grade. But let's say quizzes or tests, or in this case a final exam, is a little different than a grade. We need everything the grade has, but we also need something extra. So you come in here, we notice the first thing you'll notice, it says public class final exam extends grade activity. Wow. This is what this is saying. Extends grade activity says, give me everything that grade activity has. All of the instance variables and all of the getters and setters and all the methods. So give me everything. So now it's like we've copied everything out of grade activity and we basically have pasted it into final exam. So here's what we do. So now when I instantiate final exam, via my constructor, it looks like I have an int and an int signature, and it's looking for the questions and missed. And inside of there, it looks like it has a local variable called double numeric score. Here it says num of questions equals questions, num missed equals missed. So here we are setting our instance variables to whatever we bring in through our parameters. And then I say point each. So here is, do I have points each? Oh yeah, so points each is another instance variable, and that is equal to 100 divided by the number of questions. And the numeric score is equal to 100 minus missed times points each. So this is kind of slick. It's kind of a generic final exam that can be used by just about any exam. We take the number of questions, divide it by 100, because each test is worth 100 points. We divide it by the number of questions, and that's going to give us how much each question is worth. And then when I put a score in there, the score they actually received, I take that minus the 100, or sorry, the 100 minus the number of points they missed. I'm sorry, number of questions they missed. Sorry, number of questions they missed times points each. So now if they missed 5 questions, we now know how much each one of those questions is worth. We take that times 5 and we subtract that from 100. We now have a numeric score for that particular student. And then I say set score numeric score. So here's my get points each and get num each. Okay. Now, if we look, you'll notice we have set score right here. And if we look down here, you notice there is no set score anywhere. Where does that come into play? Remember, set score is in the grade activity class that we inherited. So again, we have access to everything inside of grade activity. So we are still inside of the final exam, but we have all of the methods and properties of the grade activity. So we still have those as well. So now someone could say final exam dot get grade, and it's going to return a grade. So pretty cool stuff there. So let's go ahead and I think there's a final exam demo. So if we look at the final exam demo, it's a void main. Here we've got our J option input questions. So we're looking for the number of questions. We're looking for how many questions did the student miss. the final exam, so we're instantiating a new object exam from the final exam class. Remember, it's inheriting from grade activity, so it has both of those as well. And then I have a J option pane. Each question counts, gets number of points, exam.getScore, exam.getGrade. And again, the exam has does not have a get score or get grade in it that we saw, because again, we inherited that from the grade activity. So if we go ahead and run this, it will come up. There it goes. So how many questions on the test? We're going to go ahead and say there's 85. And we're going to go ahead and say the student missed 10. And so each question counts as 1.17. You can see it goes on forever there. And so the exam score is 88.23. The exam grade is a B. So pretty slick there. Now in a real world situation, we would probably do some kind of a rounding factor using our decimal format in both of these cases. So let's go ahead and debug this so we can kind of see what is going on. So I'm going to go ahead and I'm going to set a breakpoint right here. I'm going to go ahead and run debug. So how many questions? Again, we'll say 85. We're going to say they missed 10. And then we're going to click OK. So now we're going to go into debug mode. So as we're going to debug, see that the so here's our questions, 85 and missed. So here we are inside of the final exam demo. So now I go ahead and I'm going to go ahead and step into. So I'm going to step into. Now notice I'm in grade activity now. So it says return score. And the reason we're inside of grade activity is because remember, final exam inherited from grade activity. So this particular piece is inside of grade activity. So we're going to look, it looks like we're inside of grade activity. We're really inside of final exam. I go ahead and return the score. So we go ahead and get score of, let's see, do you know what the score is? So anyways, let me step into the next one, get grade. And again, that's part of grade activity. So we basically go in and we can see that let's see what was passed in. So none missed, none questions, point each. So the score right now we know is 88.23. And so we're saying if the score was greater than or equal to 90 given A, we went past that. Now we're checking to see if the score is greater than or equal to 80, and it should be because it's 88. We go ahead and set the letter grade equal to B, and we drop out, we return the letter grade. And so now when we come back to here, we should see well, I think we should go back up to the top. Yeah, so this is where we go ahead and display that box. Okay. So as you can see, it looks like we're going into grade activity, and in a sense we are, but we're going into the grade activity part of the final exam. So again, we have to realize where we are in the process. Okay, we'll go ahead and stop right there, and then we'll come back to superclass constructor on page 629.